In this video, we're going to look at another example of analytical geometry. This one I can see there's quite a lot of angles. And so what's buzzing through my head is just tan theta equals m. That's the way that we work out angles, m being the gradient. And so let's dive into the question. So B is a point on the y-axis. We've got bits of the coordinate of A. We've got nothing of B. We've got C and D. These are all vertices of a rectangle, and so immediately I just want to fill in if it's a rectangle, then these lines will be equal, these lines will be equal, the diagonals will bisect and be equal. So all of this you're filling in before you've even begun. The diagonals BD and AC are drawn. The inclination here is A, and BAC is theta, and because these lines are also parallel, if it's a rectangle, that's going to help me with any gradient related questions. I could also do something like getting theta down here because of alternate angles, and so there's a lot to think about just by a tiny statement like it's a rectangle. I personally like to fill in as much as I can before I begin, so that by the time I get to questions they just flow. So determine the gradient of CD. That should be a pretty standard question. It's just the gradient formula. So it's the change in y over the change in x, and that just gives us 6 over 4, which is 3 over 2. Calculate the size of A. That's also pretty standard for you, hopefully. So tan theta equals m, or in this case, I'm going to call it A because there already is a theta. Tan theta equals the gradient, which I've just worked out. And if I need an angle in trig, I just shift tan 3 over 2, and that gives me 56.31. Determine the value of y. So y is stuck up here, but I know that these two are perpendicular, and so if I have a perpendicular, that means that the gradient of DC times the gradient of AD should equal -1. I know the gradient of CD, I've just worked it out. And the gradient of AD, I can work out. It's not going to be pretty yet, but it's the change in Y over the change in X. If I times this across, I'll end up with y minus 6 over minus 3 equals negative 2 over 3. So I've just taken the 3 over 2 across. If I times this up, I end up with positive 6. If I times the 3 up here, I end up with 3y minus 18. When I take the 18 across, it pluses, so I get 24. So the y value is just 8. Last question, calculate the size of theta. Now, because I've done alternate angles, and I would say that in an exam, I would state that I've done alternate angles, I actually would be better off just working out this gradient of the whole thing, because I already know that this gradient of A, this size of A is 56.31. And so if I work out the gradient of AC, it would just be the y value at A minus 0 over 4 minus 3 gives me 8 over 1, which is just 8. Then if I do tan theta equals 8 and I shift it, and this is not to get theta, maybe to be safe, let's rather just call it tan AC, and there's nothing here, so I'll just call it X. If I shift tan that, then the entire angle there ends up being 82.87. So if I know this whole angle is 82.87, but I know that the little a is 56.31, I can just subtract them to get my answer. And so theta would just be 82.87 minus 56.31, and that leaves you with 26.56 degrees. I hope that you found that helpful, If you did, please like this video, subscribe to our channel, and share this with your friends. Thanks.